Good evening, everybody, and welcome to another episode of vBrownBag. This will be a continuation of our Python for DevOps series, talking with Python developers and learning how to level up our skills. Tonight, I am very excited to present that we're going to be talking with Eric Matthes, the author of one of my favorite Python books, Python Crash Course, now in its second edition. I highly recommend you go get it. Before we actually tip over, Eric, are you still there? I want to make sure that.
Yes, I am.
Awesome. Hey, all right. So before we get started, let me do a couple of quick housekeeping notes. If you want to get in on the conversation, you can do it one of two ways. You can either at vBrownBag on Twitter or hashtag vBrownBag. I'll be paying attention to both of those, and you can pose the questions to Eric via that mechanism. Or if you are in our live studio audience this evening, you can ask a question via the Q&A in there. I will be fielding them and asking them to Eric as appropriate. So again, this evening we've got Eric Matthes. Oh, I forgot to give the title. What's wrong with me? Learning Python, Foundations to Real World Projects, presented by Eric Matthes. All right, so Eric's going to be our guest. If you want to follow him, you can at @ehmatthes. He is on there as well. And if you want to make fun of me, I'm also at Mistwire. So without any further ado, Mr. Matthes, I am going to turn over the power to you.
Thank you.
All right, you are the presenter, sir.
All right, so does this look good for you?
Yes, we can see your screen.
All right, hello everyone. Chris, thank you for inviting me. I am a high school teacher. I've been a high school teacher most of my life, and writing this book has felt like it just expands my classroom to more and more people to talk to. So I'm going to share a little bit about why my background, why I wrote the book, what things have come out of that, and then spend some time on expanding on a little bit of what people can learn from both the book and just once you know the basics in Python, how far can you take it? How do you start to take it farther? Sound good?
That sounds amazing.
All right. And I think it's fair to share with people that I met you at PyCon in May this past spring. And Chris pulled me over to a side table and said, let's start talking. And we started to get into a really interesting conversation. And then he stopped and said, stop. We're just going to continue this in the fall in front of other people. So.
well, tell the whole story though. I was sitting there talking to the guys in the AWS booth, and I was looking for Python presenters, and I had already spoken to you via Twitter, and I didn't know what you look like, and you had said yes, I'd love to do an episode with you, and I was talking to the AWS guy about you, and you heard me talking about you and came over, and I didn't know what you looked like, so I thought you were a guy getting ready to ask questions of the AWS person. So I'm sitting there fanboying over you, talking about Eric Matthes and the book and everything, and you're like, "Hey, Chris, what's up?"
Yes.
and then everything else happened. So that's
yes.
that's my favorite part of that story.
Yeah. The fanboying was surprising. Welcome, but surprising. All right. So, you know, a bit of background. I think this background is important because all of us, although we're doing technical work, where we come from and our experiences affects the kind of work we do and what we bring to our organizations and projects. So I grew up in New Hampshire. I was born in Guam. My dad was in the service, but my family is from New England. So I left Guam when I was 6 months old and grew up in New Hampshire.
Represent.
My dad was a programmer in the 70s and 80s. So I grew up with a dad who programmed starting on punch cards. And the very first computer I used was a kit computer in our basement. It had a bare keyboard with a wire showing, a bare cathode ray tube, and a bare motherboard. And that was my first experience of using a computer. So I'm going to skip ahead for a moment. This was me in 1974. Just before I got to use that kit computer. So I like getting older. I like the range of experiences we get to have in a human lifetime. I'm a little jealous of all the younger people who get to grow up with computers as powerful as they are, but I also appreciate having grown up when computers were less powerful and we had to be more careful with the resources that we had. So I grew up in New Hampshire, and I spent my first 20 years of life in New Hampshire, and then I moved to New York City to become a teacher. I got a BS in physics. I started college majoring in chemical engineering because I had an AP chemistry class in high school that I really liked. But I got to college, my first engineering classes struck me as more learning how to solve other people's problems than understanding the world. And as a young idealist, I really just wanted to understand the world. And physics felt like the class and subject most in line with just trying to understand how the world works. So, Chris, did I tell you I was going to be a particle physicist?
You did not tell me that, no.
Yeah. In my quest to understand everything. But when I was getting close to graduation, I realized I did not want to be a student for another 8 years. I wanted some experience in the real world. So I decided to start teaching because I had been tutoring calculus and physics in college and found it really satisfying. So I started teaching, moved to New York City to start teaching, and I found that the challenge of trying to reach everybody was as intellectually satisfying as hard science. And that's what's kept me in teaching. That's what kept me from going back to physics. So I taught New York City for a while, and being 22, 23 years old and having a summer off for the first time is a pretty interesting experience. So what I got into was bicycling across the US. And I mentioned to Chris before the broadcast is starting that he asked me how I came to Alaska, because I'm in Alaska right now. And after a couple of summers of bicycling across the US, I liked bicycle travel so much that I wanted to live outside for a year. So I lived outside on a bicycle for a year. I flew to Seattle with my bicycle, and I rode across the US and Canada to Maine, rode down to Florida, across to California, and north to Alaska. And that's how I first came to Alaska.
I have so many questions about that, but they're not appropriate for for the vBrownBag. You should write a biography.
Yeah. Yeah, I understand that, but I also think it's important to share those kinds of experiences because they do flavor how we approach technology. So having lived outside without technology for a year has grounded me when the technology becomes overwhelming at times. So I've spent 25 years as a teacher from middle school through high school, and I did learn programming around 7 or 8 years old from my dad. My first programming was in BASIC. With GoTo and whatnot. And my first program was a number guessing game. And I remember watching my parents play it and just feeling so good watching other people use a program that I'd written. And, right then it was about more than just the code. It was about how that impacts people. So I started at a young age and I learned C, Pascal, Fortran, any number of those older languages, always as a hobbyist. Always for a class or just out of curiosity. And around, I forget if I told you this. My life as a programmer changed in 2011 because my son was born, and a month after my son was born, my father died. Did I tell you that at PyCon?
Yes, he did.
Yeah, and so, I say it with a smile on my face right now because enough time has passed to have perspective on this. At the time, it was pretty devastating because my parents had never come to visit me in Alaska, and they had planned their first trip for that summer to meet our son. So his passing when my son was a month old was pretty hard. But one of the things I did, we went back to visit my mom and be there with her at that time. And she asked me to go through my dad's computer and basically see, is there anything worth keeping or that she should know about? And as I went through my dad's computer, I saw all these projects that would never see the light of day. And I realized that if I died that day, somebody could go through my computer and see all these projects that would never go anywhere.
Mm-hmm.
So that experience kind of grounded me over the next few months in being very intentional about finding something that was worth applying my programming skills to. So I jumped into trying to build some open source projects that would make the field of education better. And that's what led me to PyCon in the first place. I knew I had programming skills. I knew I wanted to apply them. I wasn't quite sure what to do with them. I had a friend who told me that Python is great, the language is simple, and the community is even better. And I don't know about you, but I was really nervous the first time I went to PyCon.
Yes, definitely.
Yeah. For me as a teacher first, I had assumed that technical conferences were very technical, everybody would know more than me, and I wouldn't really have a place. And I very quickly found my impression of PyCon has been that about half of the people there are primarily programmers, and they're looking for meaningful problems to solve, and half the people are people from other fields who are looking to use programming to solve the problems that they are trying to wrestle with.
Mm-hmm. Yeah.
Does that strike you as a fair assessment?
Absolutely. Yeah. I had the same fears. I was definitely, I was a little bit in a different boat. I had only been programming for 6 months before Calvin convinced me to go to PyCon with him. I'm super glad that he did, but the atmosphere there is unlike any other conference that I've ever been to. Definitely very high level, very technical people, but also unusually, extraordinarily welcoming of newcomers and people that have a business problem that they want to solve, or a scientist that wants to. I mean, that's why pandas and NumPy and all of those are so popular, is because the programmers are very willing to help the non-programmers out in the fields.
Right. Yeah, and whether that means helping you out or just kind of guiding you in the right direction. My impression was the same as yours. I felt very welcome. I remember people just sitting with me that first night and just asking what I do and being genuinely curious. So I ended up giving a lightning talk at my second PyCon 2013 about how the education world could benefit from some open source principles, not just free software, but open source thinking. And Bill Pollock, who is the publisher of No Starch Press, the owner of No Starch Press, was in the audience, and he came up afterwards and said if I ever wanted to write a book, to get in touch. So that's how I got diverted onto the path of writing instead of programming. Just to leave this slide, I also do mountain rescue. This is, I think, we'll get to the technical stuff in just a moment. You were asking where I am. Chris is from New Hampshire, where I grew up, and he asked if we're on the same parallel. So New Hampshire is over here, and I am up here in Sitka. And so Sitka is on Baranof Island, which is this island right here. It's about 100 miles north to south, about 15 miles across. And Sitka is this little strip of land, 14 miles from one end of the road to the other. And you can only get here by boat or plane, and the rest is wilderness. So that is where I am.
Wow. So you can only get to your place by boat or plane?
That's correct.
I have even more questions, but I will save them for after this episode.
Yeah. Anybody who asks any questions on Twitter or whatever, I'll answer everything that comes my way. So I do mountain rescue because people do get lost here. And yeah, it is pretty satisfying and enjoyable work. And again, something that I did not expect to get into in the course of my life. I just left the classroom. I've been a teacher for 25 years, but writing this book has become a second job. And so this past year was the time to leave the classroom and start focusing full-time on writing and programming. But I also get to go back to the mountains. So it's been nice to climb mountains while other people are in school, cut firewood. I'm sitting in front of a wood stove right now, and it's really nice. I'm going to come back to this if there's time, because we'll focus on the technical stuff. But Chris, do you know what these are?
Are those monkfish?
These are halibut.
Oh,
Um, and so we are allowed to do subsistence fishing here. And a subsistence longline is where you drop like 1,000-foot line on the bottom of the ocean with like 15 hooks on it,
mm-hmm,
leave it overnight, and come back and pull it up the next day.
mm-hmm.
And in the morning, hopefully, you find things like this. So I mentioned that partly because I feel strongly that everybody in technology work really needs something outside of technology to kind of ground us in non-tech things and keep perspective on that. That said, I'm going to show you briefly my actual programming work. One of the programming projects I'm involved in is Longline Mapping. Longline is where commercial fishermen take lines instead of 1,000 feet. They take a couple miles of rope, put it on the bottom of the ocean with 1,000 hooks, and they try to catch as much fish as they can.
Wow.
And so part of my work has been I try to find projects that are happening locally where people are doing interesting work and they don't have programmers on their teams. And if I can spot inefficiencies, which is oftentimes just simple data analysis, then I jump in on that project and help out. So this is a long line. I think I'll go through this and then we'll jump to the technical stuff.
Okay.
So this is a long line. When I set this for our family's subsistence use, that line is 600 to 1,000 feet. When commercial fishing people do that, it's 2 miles of rope. And so the green dot on your screen is where they put the first hook. The red dot is where they put the second hook. And then there are programs that record the latitude and longitude position of every fish that comes on board that boat. And then this is what that pattern looks like, because the boat is just kind of drifting around while they're pulling fish on board. Is that making sense so far?
Yes, yes.
All right, so the question that fishermen have is, where are the halibut that I want to keep, and where are things like rockfish that I want to avoid?
Mm-hmm.
And so what we do is find where all those hooks are on the bottom of the ocean, and then map each section of hooks to where those fish actually came from. So whenever a fish comes out of the water and onto a boat, we do some analysis to say to the fishermen, this is where you actually got that fish on the bottom. So the long-term goal of this is that fishermen can catch more of the fish that they want, not just to take all the resource, but to focus their fishing on the species that we are eating and avoid catching fish that just die in the process.
Gotcha.
Yep. So this is part of why I'm really happy to be able to leave the classroom, because I miss teaching, but the more I get into teaching about programming, the more I need some real world projects to make sure that what I'm presenting is actually meaningful.
So there is a quick question about the longline fishing, actually.
Sure.
How is the data recorded?
Data, oh good, that's a great question. There has always been, or for a long time, there's been some monitoring, and at some periods that has been a fisheries representative who lives on a fishing boat and watches what happens and watches for compliance. It's kind of like random monitoring. Mm-hmm. Captains can choose video monitoring, where they have to leave a camera running the entire time they're fishing, and then people have added on things like automatic positioning recording devices, and so there are people who are paid to watch the footage when they're hauling fish in and tag what kind of fish comes over the onto the boat and at every point. And they enter that into an Excel spreadsheet. I import that, process the data, and spit it back out to somebody who has expertise in mapping.
Gotcha. Cool.
And the fishermen get a map back that tells them where they should target their fishing.
Right. Gotcha. Cool. Thank you.
Yeah. All right. So, like a good teacher, I over-prepared. So, the only thing I think that's worth sharing with people is these 3 slides, then we can do the technical stuff. All right, so why did I write a book in the first place? I got into Python because I was using Java in the mid-2000s. Somebody told me that my Python code would be 1/3 as long as my Java files, and I tried it, and they were right. Did you have that experience?
Yes, absolutely.
Yeah. So I like many languages. Python is not the only language. People should be familiar with a variety of languages, but I've stayed with Python for the community and for the efficiency of what you can do with it. Um, when I was trying to teach Python in 2012, 2013-ish, I found that every resource I shared with my students was either aimed at little kids or it made too many assumptions about what they knew.
Mhm.
And so when I got invited to write a book, I went back to my classroom and I saw that I had a poster on my wall with this question on it for my students, because my students didn't want to learn programming. They wanted to build games. They wanted to analyze data that they cared about. They wanted to build web apps. And so I had a poster that said, what's the least you need to know about programming in order to start working on meaningful projects? And I realized that was the guiding question for the book I wanted to write. And when I teach, these are the principles that I use. Of course, I have to simplify things, but I always want to treat people with intellectual respect. I basically approach my learners, whether they're students in a classroom or people reading a book that I've written or whatever resource, trust that a solid foundation in the basics will allow those people to be independent lifelong learners. When you create introductory learning materials, you have to simplify things. My goal is to simplify things in a way that people can build on what they've learned, but never have to unlearn anything. My favorite example of that is when a teacher tells a kid that you cannot take a big number away from a small number. And we know that's not true. There's ways to avoid talking about negative numbers without saying that they don't exist. And then the last part is to show people real-world meaningful projects that can be extended in a variety of ways. And those projects should come from the basics that people have learned. So that is how I think about teaching, and is how I thought about writing the book. Do you or anybody have any other questions that we should cover before jumping into some technical pieces?
One moment, let me scour the internet. No, and no, we're good. Thank you.
All right. What I'd like to do for the technical pieces, we're gonna, I know you have some viewers who are just scratching the surface of programming in Python, and you have some people who've been using it professionally for a variety of purposes. So we're gonna touch a little bit on lists and dictionaries, not so much what they are, but you'll see them. We'll say a few things about them as they come up. Functions, we use requests, which I know has come up. We'll work with an API, and we'll get into multi-threading.
Awesome.
Yes, there is oh, here we go. You need to see this. I am an intermediate programmer. As somebody who has been a teacher most of my life, I have done some real-world programming projects, but they've always been projects that just require some programming to automate some work and make things possible. There's a good number of people who think I must be an expert programmer because I wrote a book. But my expertise is more in teaching and learning, and using code to solve real-world problems, and knowing when I need to call in somebody with more programming expertise. So, good perspective. I assume many of your viewers are like this, and yeah, it's a good place to be.
Yeah, I think that some people that say that they're just a beginner vastly underestimate themselves, and some people.
Yes.
Well, I don't think that there's a lot of people out there that bloviate too much and say, "Oh, I'm an expert," and they really aren't. I think technology people are more humble than not, but it's really interesting that you consider yourself to be an intermediate programmer, because after reading your book and going through the practices and exercises, it's an interesting perspective.
Yeah, it's a good place to be. You can do a lot as an intermediate with an awareness of how to use programming in the world. All right, so here's what we're going to do. When I present something in the classroom, I know that it's easy for people to nod along and say, yes, I get this. But you don't really know that you got something unless you can use what you have been learning to do something. So I'm going to give people a closing challenge, and if I do this right, then you can complete this challenge. So one of the projects in Python Crash Course uses the GitHub API to explore the most popular Python repositories. It basically makes a single API call that says what are the most popular, what are all the Python projects on GitHub, sorted by how many stars does it have, and give me back like the top 30 repositories.
Mm-hmm.
So you can do that with a single API call. So if people understand what I present, which will involve a little bit more than just watching this, but playing with it and trying it out, you can do the following. Find out who the contributors are on the 100 most popular Python repositories. So do an API call or a series of API calls that get you the 100 most popular repositories, and then dig into this question. How many people contribute to more than one of these repositories? Because you can take a repository, make an API call, and get a list of everybody who has contributed to that project. So how quickly can your program answer this question? Using the basics, it's not too difficult to make a program that will fetch this information, one piece of information at a time, and then process it. But if you want to do that in a meaningful time, it requires some interesting uses of threading.
Mm-hmm.
Does that make sense?
It does. Is that alluding to async and await?
I'm not sure.
Ooh.
I will admit one of my Googlings today. I've Googled this before, and I will again. Multiprocessing versus multi-threading versus async versus AIO. So, yeah, I told you before this started, I'm going to write a blog post that summarizes the technical aspects of this.
Awesome.
So, again, any questions that come up, people are, whether they get answered during this hour or not, I will follow up with them.
Totally.
All right. So, I made some things to help out. So this is my blank slate live. Because if we're going to watch people program, it's fun to watch from a blank slate, because that's what we all start with when we're working. All right. So, you mentioned virtual M's, and they are a good thing to know about. So if anybody hasn't seen this before, let's see. Here's my blank folder. I did make myself some partial programs, so if live coding gets messed up, I'm not lost completely. But a virtual environment is this. So we make a new virtual environment called HN environment because we're going to focus on the Hacker News API. I'm aware that Hacker News is a good place for some people and a cesspool for others. Their API is pretty easy to work with and doesn't require authentication. So what we've done is we've just made a Python environment that is just for this project. So to activate it, source environment bin activate. All right, and we now have an environment that will hold any resources we need just for this project. All right, so the one that we're going to use is requests. So for all of your viewers who use virtual environments, good, keep doing it. If you have never seen them or they've become confusing, they're worth investigating, and I'll happily answer any questions that come up about them.
So we actually have, in a previous episode, we had somebody explain and go through virtual environments. And then in another episode, we had somebody talk about how to import and install modules using pip. So if everybody has been following along at home, they should know exactly how to do both of those things.
Good. And I think, when I first learned about virtual environments, I had a presentation like that, but then I didn't see them used very much. So I like to just use them when I can. So we're going to make a file, hn articles.py. All right, and let's open that up. All right, so we can write some code. Are you an HN person, Chris?
I'm sorry, what?
Are you a Hacker News person?
You know what? I haven't been. I've gotten a lot of links from it, but I don't peruse it on the regular. I've been. I get deluged with so much news that
Yes.
I don't actively seek it out anymore. I'm
Yeah,
sorry to say.
quite all right. Okay, so this is what Hacker News looks like from a private window. I'm logged in typically, so I have a private window open just so that we're all seeing the same view. All right, so this is the Hacker News API, and it's a GitHub page, and the documentation is pretty straightforward. So what we have is, here is a call for the top stories. All right, so Hacker News Firebase IO version 0 top stories is a JSON response, and this displays it to us in a pretty format. So I'm going to rerun this. All right, and so these are the IDs of the top 500 articles on Hacker News. All right, so how do we do that in code? And I think you said people saw requests last week.
Yes, correct.
All right, so here's the URL. Wrong one. All right, and we're not printing it, but we are using the JSON format. All right, and
So as you're typing that, one of the questions was, what is your preferred ID for Python? Current one that you use, is it Sublime like in PCC or in something else?
it's an interesting question. If I were just a programmer, I would use a straight Linux machine and I would use Emacs. But as a teacher, as an author, I need to use something that's a little more accessible to people. So I keep coming back to Sublime Text.
Gotcha.
Can you see this, or do I need to make the
No,
font bigger?
it's perfectly visible.
All right, good. All right, so what we have is the URL. Instead of going to add this through a browser, we've made a request, and we just see that that request was successful. All right, so another API call you can make is to take any one of these articles. So if we refresh this screen, all right, the top article is still about smart TVs sending our data to Netflix. So that should be this first article ID that was returned from the API call. This right here is the API call for getting information about a specific article. All right, and ooh, Navy confirms UFO videos are real.
I saw that on Twitter today. The guitarist from Blink 182 released something that he shouldn't have leaked or something.
Yes, teaching high school, I meet many students who think they're real. All right, so those top articles are probably jumping positions. All right, so we can take, the point here is, all right, this one API call gives the IDs of 500 articles. And this is not uncommon for an API. Whatever your data is that you're working with, you get a bunch of information from one call. And if you want to follow up with that, you need to make other calls. So what we want to do is this. All right, so let's see. So what's interesting about this kind of thing is, let's look at this and just say, what data structure is this? Right, this is a list. So when people learn about lists in Python, a list in Python is just like a list in JSON. JSON is one of those words I never say out loud. Is it JSON or JSON?
I've heard it used interchangeably as JSON and JSON. I think the consensus is JSON, but yeah.
All right, you'll see me run my code a lot. Go ahead.
I'm sorry. I was going to say it's the GIF versus GIF people.
Yes.
All over again.
Yes. You'll see me run my code a lot because I like to know, have I made a simple mistake before I move on? So what we have now is we have this list of IDs, assigned to this variable called submission IDs. And here's what we want to do. For submission ID and submission IDs, and we want to get information about an article. All right, so we use requests again. And let's see, before we do that, we have to build the URL. Because this URL is the same every time you want the top stories from Hacker News. This URL is going to be unique to each article. All right, so here's the URL we used for the top article. We can start with that. And again, we're not printing it. All right, and this is the value that we're assigning programmatically, and that's submission ID. All right, and for now, let's just print the status code. All right, so remember, there are 500 IDs here, so we don't actually want to make 500 calls right now. And so we can take a slice of that list, and let's just do the first 5 articles. All right, and so we should see a series of successful requests. Oh no, r.status code. For any viewers who haven't heard this, everybody makes mistakes every day. You make mistakes, whether they're typos or conceptual mistakes. You are not alone. All right, so this becomes more interesting with a few more articles. So let's just look at the top 10. All right, so that's 4 seconds. All right, so what we're going to do, I'm going to throw this in right now because this is the whole point. Chris, you said you have played with threading and async. Can you share briefly?
Yes, sure, go ahead.
Oh, I was going to say, can you share briefly what you used it for, or were you just playing with it?
Oh, I was just playing with it. A couple weeks ago, Mike Kennedy came on and gave us an example of how to beat up a website. And so I didn't beat up a website. I went out and grabbed five different requests simultaneously, or used a piece of code that didn't have async in it, and then sent out 5 requests, and then wrapped it in async and await and watched how fast it would increase. So that's what I did basically.
Cool. Okay. So for structuring files, we're going to import threading, and I'm not sure if it came up during the module presentation. There's a convention in Python to import modules that are part of core Python first, and then import third-party modules. So it's just a nice organization thing where you can see what's being used from Python, and you can see what's being used from external libraries. All right, so I had not used multi-threading for a while until today. So I'm going to try this. What was it? All right, okay, so we need a function. We need a function that we're going to call from each thread. So what we want to do is process each article. All right, and so I'm going to call this article ID. Chris, you know the 3 difficult things in programming, right?
What's that? I thought it was all difficult.
The 3 difficult things in programming are naming things, cache invalidation, and off by 1 errors.
Gotcha.
Have you really not heard that before?
I've heard permutations of that.
Okay.
And it always ends in off by 1 errors.
Yes.
Gotcha.
I was going to be honored to be the first person to tell you that. I bring it up because I think it's absolutely critical, especially for people who are not programmers first, to understand that naming things really does affect how we think about them. One of the interesting things about Python Crash Course getting more popular has been how many questions I get on a regular basis through email, Twitter, whatnot. It's just the right volume where I can still answer every question that comes my way. But a good number of them are because people have chosen names that don't let them think clearly about the problem they're trying to solve. So we have like submissions and articles, and so do I call this process submission or process article? Trying to be careful and constantly rethinking your naming is a good thing. So we're going to get information about a specific article. And I notice that's the same thing I wrote down here, and we're kind of moving some of that logic to the function, right? When I move things around, I often copy and then get rid of things, and then cutting helps me make sure that things are getting moved the right amount. The work that's taking time is that request. All right, so that's what we want to move to a function. All right, so before we speed this up, let's just call our function. All right, and we're calling it with the URL. All right, so this could be done in a couple ways. I think when I was practicing this earlier today, I sent this submission ID. This time we're just sending the URL. Shouldn't make any difference for what we're doing. All right, good. Everything's working. Same speed as before. All right, so what we want to do here, if I remember this right, we're going to create a thread. And the target for that thread is our function process article. And we're sending it one argument, and that is the URL. And it has this weird convention that I don't understand yet where it has space for a second argument. And instead of calling that function, we want to start that thread. Right, so we don't call the function, we start the thread that will call that function. I'm not sure if I remember that correctly. Let's see if I did. All right. You said it was Michael Kennedy that presented recently?
Yes, sir.
Did he present the same structure, or was it something different?
It was different because he didn't use the threading call. He actually used an async and then an await call wrapped around the request.
Yeah, one of the things I'm going to do to follow this up is look at the variety of ways you can do this.
Mm-hmm.
I'm assuming you saw similar results.
Yes, absolutely.
Yep. So I don't know what's better, this or what Michael presented. My guess would be Michael.
Nor do I.
Yeah. The bigger point for viewers, a lot of times what you need is, if you're not a programmer first, what you need is something that works for your problem. So if what Michael presented works for your problem, good, run with it. If what I present works, run with it. At some point, if it is a critical project, be asking the people who know more about it whether you are on the right track. But clearly this is working for us. We have sped things up, and it's amazingly so.
Mm-hmm.
All right.
Absolutely.
All right, so what we want to do, we want to actually summarize some information. All right, so we're getting information about these articles. And let's take a quick look at the information we get about an article. All right, so we get the title of that article, we can get the URL for that article, and we can get a few other things. All right, I'm going to keep this pretty simple. So I'm going to define a list because I want to collect the information that we're getting. All right, so when people are looking at API calls, it's good to look at what are you getting back. All right, so we're getting a dictionary back. So we call that article dicts, and can get confusing because we're getting article dicts, but we're putting it into a list. So we're getting a list of dictionaries. All right, what we want to do is Yes. Rather than just printing that status code, we want to, here we go, article dict is the response, the JSON encoding of the response. And so we want to append the article dict into that list.
Got it.
Does that make sense?
Yes.
All right, so let's conclude this by just seeing, oops, how long that list is. So how many dicts did we collect? All right, we are going through 10 articles, so we should see 10 article dicts. Do you know what we're going to see?
The number 10?
We should, but I don't think we're going to, so let's try it. All right, it's not clear. One of the interesting things when you play with threading is that things are no longer linear. All right, so we are printing the status code right here, but whichever thread finishes first prints its result first, and so you get things in nonlinear order. So let's clarify this just a little bit. So we're going to print the status code, but then we'll also print the URL. All right, and we'll do the same thing here. Yep. Still getting used to F strings, right?
Mm-hmm. I love it.
All right. Yeah, I do too. Oh, they're so great. All right, so I didn't put anything in there. I found this many articles. Oh, I wonder if yeah, max retries. I used the API too much.
Oopsie.
Yeah, I'm assuming it's a,
They caught you.
yeah. That's why Michael targeted his own site, right?
Right, exactly.
All right, so, yeah, so what we notice is, what happens is, this is the very first thing we asked to print, the status code for the original top stories call. That is right here, 200. We do all this work, and we think at the very end that we print a summary of what we found. What actually happens is our summary happens before any of the calls finish. Right, and that's what happens with multi-threading. We are asking Python and the computer to start a bunch of threads because we know these things will take some time and do them. But when we do that, Python just keeps running through all of our code.
I see.
So what we do, this is so interesting. I love this stuff when I first came across it. I've used it in one real-world project, which I'll describe briefly before we wrap up. So what we're going to do is just keep track of how many threads we have. All right, so there's a list for our threads. And every time we start, I'm pointing to my screen in my living room. Every time we start a thread, we are going to append that thread to our list of threads. All right, and there's something called joining. For thread in threads, thread.join. I'm going to put T because that's a convention I've been using. T.join. All right, and I believe what this is going to do is when you join a thread, it's basically saying, I want to make sure this thread finishes before we move on in the program.
Cool.
All right, and it worked. So this 200 is the status code for the initial call.
Mm-hmm.
And then we get all the status calls for the threads. The join says, join at this point in the program, join all those threads, don't do anything else until all those threads have finished. And then when that's done, program execution moves on, and we see all those articles. All right. Does that make sense?
Yeah, yes, it does. This is awesome.
Yeah, did that come up at all in Michael's presentation?
Nope, not at all.
So I'm going to be, one of my open questions is going to be, I think I'm going to try to do this using the async await and see how this issue plays out in that structure.
Yeah, I'll be curious to know how that pans out.
Yeah, one of the things for people to realize is if you have different kinds of threads, because all of our threads are the same, they're all making requests, and we can't do anything else until we move forward. If you had a more complicated program with different kinds of threads, you don't have to do this loop of joining every thread. You can join just the threads that are critical to complete before moving on. All right, I think, oh, the other thing that would be nice to do, I think we can change this to like 50 articles, and I think it's still gonna work pretty quickly. Yeah, there's one request that failed.
Max retries.
Max retries. Yep. And typically that's because this is an unauthenticated API. And so typically when you are using an API that you have a key for, you don't run into these lower limits. But the bigger point here is in 1.3 seconds, we found 49 articles. And if we had done this without threading, that probably would have been about a full minute of execution.
Mm-hmm.
So I could do a little bit more in my playing this afternoon. I printed a nicer summary than just the status. Like we can go for article dict in article dicts, and we can print the article dict.title. Right. I don't think it's too important to do that. Oh, here's where I'd rather wrap up. All right, so one of the things I mentioned pretty briefly is the projects that I have done. Oh, here we go. All right, so I'm an educator first. I love education. I think it has the potential to be one of the equalizers in society. School is different than education. Schools are not always equalizers. And so I have worked with students who are at risk of dropping out for a good part of my life. These are students whose parents died during high school and they got off track, and by the time they had pulled themselves together enough to pay attention to school, they're behind, and students with any number of issues. So when you start to work with people for whom school is not easy, or for whom school has not gone in a straightforward way, you get situations like, okay, you need 3 credits of science to graduate. I passed everything sophomore year except for my physical science class, and basically the transcripts are messy. And so for the schools I've worked at, high school transcripts have been text documents. And so I have had countless parent-teacher conferences where I sit at one side of a table, I have a student's transcript in front of me, and literally 20 minutes of the conversation is just marking up the transcript, showing where they have earned credit, where they have not yet earned credit, and figuring out which classes they need to take in order to graduate. As a data person, I know that information can be presented much more simply. So I wrote a program that scrapes all of our students' text transcripts, and it spit out a series of bars. So it would say language arts, there'd be a gray bar that is 4 credits long, and there'd be a green bar on top of that is 2.5 credits long. And it would do that for each subject area, and all the little, like, social studies to graduate, to earn credit to graduate from social studies, you need 3 credits of social studies, but 1 has to be U.S. history, 1 has to be government, half has to be Alaska studies, and half has to be global issues. So that's why it takes half an hour to process a text-based transcript, especially when students can earn partial credit in some classes. So I wrote a program that scraped all of our students' transcripts and then spits out these documents that I and a parent and a student can literally look at in 30 seconds and see exactly where they are. And I like to tell people for that kind of work, a lot of people think, oh, you just saved half an hour. It's great. What I found was our student conferences were no shorter. We still spend half an hour to an hour with the family, but instead of half an hour being dedicated to just figuring out where they are, that half hour is now focused on here's where you're at, where do you want to go, how do we get you there? And so educational software is not very good overall. Some of it has really good aspects, but the profit motive in education is just makes so many educational software packages hold back. So every district has something called a student information system. Basically holds all the data for all the students in a district. I can take that data and present it meaningfully to students. You probably could too. Many of your viewers could. And the companies that make these information systems have chosen to not include APIs and shut down APIs when they have existed because they recognize that we are just going to make things that are useful and make their software less needed. And that holds back students. So anyway, to wrap that story up, we were working with an information system at one point that did have an API, and I have so much respect for them. It's Schoology. It's like, it looks like Facebook, but it's student information. And you could write an API call for every student. So in a school with 450 students, that was 450 API calls, and their structure was not the greatest. So you actually had to I had to query each teacher in the building, find out all their classes, write a query for each class, find out all the students, and then write a query to find out all their grades. So it's an insane number of separate calls. So what we just saw, instead of 20 calls for HN articles, this was 1,500 API calls for generating student data. So I did use what we just saw. I used the multi-threading that we just saw to run that, and it made that program run in a reasonable time. And in the end, it actually meant that students understood where they were at in their education, and more people graduated because of that.
That's awesome.
So this stuff is useful. That's about an hour. I'm in no rush.
Well,
going back to this. Go ahead.
I'm sorry. Go ahead, please.
All right. Going back to this closing challenge. I wrote this inspired by one of the Python crash course projects, but that line of selling your projects and just saying interesting things is always interesting. You do not need to read my book to do this challenge. The GitHub API is pretty well documented, and so it's not hard to find an example of how to make the API call that gets you all the repositories. You can take what we went over today and use that to follow up on each of those repositories, get the list of contributors, and then I'm curious about this. I started to run this today. It's a little more complicated than the example we worked with because you're doing more with the data once you have it. But I'm kind of curious, of those 100 or 1,000 most popular Python repositories, are they all different people, or are there a few key people that are contributing to a number of those? So it's a pretty interesting challenge, and I'd be curious to know if people end up pursuing this.
As a raft of programmers go out and just start hammering all of these different websites.
Yes, they're used to it. It's
I'm
good.
definitely going to play with this. I'm going to try it with the threading and with the async await to see what the differences are. That's going to be cool.
Yeah. If you find that out before I do, please let me know what you find.
Oh, I will, absolutely.
Yeah. Again, I'm not in any rush. So, is there anything that you wanted to go back over, or any questions from people that are worth bringing up right now?
Well, I kind of wanted to ask about the whale avoidance thing. What was that?
Sure. Yeah. You know, there's a misconception in my community that I have just quit teaching and I just stayed home all day because I wrote a book.
Hmm.
Um, but I'm actually a full-time programmer and writer. That's what I'm telling people. And it really is fun and satisfying to be able to keep an eye out on the kind of work that's being done in my community. And when programming, a little bit of programming can really make or break some of these projects. It's really nice to be able to offer that. So, all right, going back to this picture. So people are typically fishing for halibut and black cod, and they're fishing around 1,000 feet deep. So what'll happen is this boat will turn a motor on that starts this spool, and it starts hauling the gear up. And
Hmm.
remember, this is 1,000 feet of rope, and this is a couple miles of line with nice tasty fish on it.
Hmm. Hmm.
So sperm whales have learned to recognize the sound of that motor starting,
Oh
and
no.
when a sperm whale hears that, they will come over to the boat and they will hang out here and they will literally pick off every fish that comes up to the surface.
Wow.
Yeah. And so there's a group that the group I work with is called ALFA, ALFA, Alaska Longline Fishermen's Association. It's a nonprofit that does work to support the fishery overall. And so there's a team that has developed software that tows a hydrophone array and analyzes that hydrophone data and identifies when sperm whales are in the area.
Hmm.
And so um, that team has collected that data. It goes through a satellite relay, and you can have that satellite company can either email you your data or send your data to a URL. So these people knew how to detect the sperm whales. They know what they want to do when sperm whales are there, but they don't know how to build a server that listens to um, URL or listens to HTTP requests. So
Gotcha.
I use Django, build a simple Django app that just listens for calls from that, and whenever it gets one, it just dumps it into a database, and then those people query the database, and their goal is to create real-time notifications that go out to people on the fishing grounds that let them know where sperm whales are. And the goal there, it protects fishermen.
Hmm.
You know, I had a friend who asked me a good hard question with the longline mapping. He said, "So, what's the worst thing fishermen could do with your project?" And I was like, "Ah, oh, damn.
Mm.
I hope this doesn't lead to overfishing."
Right.
And he was
Right.
right to ask that question. Um, with this project, my motivation for being involved in it is anytime you have people with a commercial interest um, coming into conflict with whales, it's probably going to end up being bad for the whales.
Right.
So I feel pretty good about helping people avoid fishing where sperm whales are.
That's awesome, dude.
Yeah, it's fun stuff, and I get to like go hang out with whale scientists.
So we've had a couple of people on that were they were the IT people on a marine biology ship out in the Black Sea, and they basically spent, I want to say, 3 or 4 months at sea, maintaining all of the equipment out there, and they had fascinating stories to tell about
Mm-hmm.
marine biology and the ocean and all of the interesting scientific tidbits that they had out there. Um, I have to introduce you to them. They're really nice people. They're out getting on their honeymoon right now.
Nice, excellent.
Cool. Okay, so like you said, we are at the top of the hour. I feel like we could go on all night with this, but I want to be aware of your time. So I don't see any additional questions. So usually that happens for one of two reasons. It's either everybody is bored to tears and they've all fallen asleep, or you were amazingly thorough in your presentation, and everybody understood it, and there aren't any questions, and they're hopefully off playing with threading right now, and playing with creating functions, and going through your book. If he has more to, people are saying if he has more to talk about, please come back. Great presentation, thank you. Would like to learn more about threading. Not bored or sleepy, just enjoying the discussion. Okay, so nobody's passed out. This has been fantastic, Eric. Thank you very much.
Sure.
Did you say that you had some take your projects further stuff that you had?
Yeah. Here, I'll show this. All right, so these are the online resources for my book. You know, it's been really interesting to write an introductory book. When I wrote it, my gosh, I started tracking the hours it was taking me to write the book.
Mm-hmm.
And after 2 months, I stopped because it was so depressing. And the book took 2.5 years to write.
Wow, I didn't realize it took that long.
Yeah, I mean, when I say I was working 2 jobs, it was really teaching. And so then the writing was either like 4:30 or 5 in the morning until 7 or 8, and then like 9 or 10 at night until 11 or midnight. So that was pretty draining. But when I was writing it, my hope was to write a book that would become a foundation, one of the go-to introductory Python books for the next 10 years. And we're halfway there. It's been, well, 4 years in. But I believe that one of the things that has kept the book doing as well as it has is every time it goes through new printing, I update anything that people have pointed out that's inaccurate. And I've created these online resources, so not just updates, but also there's some cheat sheets, there's some instructions for setting up your system, there's solutions for the projects. So when I was teaching, this is all I could create. I've been looking forward to following up. Basically, I have like 100,000 people plus who have learned to Python, learned to program through this book. And so if I know they've learned what's in the book, there are a whole bunch of things I could teach them that just go a little bit beyond what's in the book. This multi-threading piece is just a small snippet of that. So I'm going to add a section to this. It's called Beyond PCC, and it's going to be a series of posts saying, now that you've learned this, here's how you can go a little bit further. These are things I don't ever plan to add to the book because I don't, learning Python, I think Mark Lutz is the author. That book is great. People should have it on their bookshelf, but it's like 1,500 pages or something now.
Right.
So I won't do that to Python Crash Course, but I do want to add some resources for people who are looking to go a little bit beyond.
Very cool.
So I'll announce that. You'll see that when it comes out, and it should be in the next month or two.
That'll be amazing, and that's going to be on the ematthes.github.io site.
Yes, EH. Yep.
EH Matthes. Okay, I'll add that to the show notes so that we can have a record of that for people to hit. I'm particularly excited about that. Like I was telling you before, I've literally have 4 copies. I have the PDF and the physical of your first edition, and the PDF and the physical of the second edition. I love that you went in your Aliens game. You went from functional programming to OOP. That really helped me to cement my deficiencies in OOP programming. So the Beyond stuff will be that's going to be super cool, especially when you're talking about the AI bots in the Alien game.
Yeah, it's going to be fun.
Cool, very cool. Okay, cool. So I said, all right, let's wrap this up, and we keep talking. So we could totally do this all night. Let's put a pin in this. Everybody, thank you so much for attending another episode of vBrownBag. Eric, thank you so much for coming on. This was fantastic. This is exactly the kind of stuff that we love showing, and obviously with your teaching experience, you were able to nail this. So it was a pleasure having you on.
All right, thank you, and I appreciate the invitation.
All right, everybody, have a great evening, and we will be talking to you again next week for what we've got 2 more Python episodes to do before we wrap the series. So we'll see you again next week. Take care.